Hello students, now we are going to see the solution of the model question paper for the subject Electronic Principle and Circuits. So the first question is, develop an expression for the operating point IC and VCE for the voltage divider bias circuit using approximate analysis. So here they have mentioned the type of analysis. So we are not going to do the exact analysis. We are going to do the approximate analysis and then calculate the operating point for the VDB circuit for given values. Values are VCC 10 volt, R1 10 kilo ohm, R2 2.2 kilo ohm, RC 3.6 kilo ohm, and RE 1 kilo ohm. So let us see what to do to solve this problem. So already I have noted down the question here. Now first we should draw the voltage divider bias circuit. So we know that circuit. So we have RC here, then NPN BJT, RE, this is RC, this is RE, and this is plus VCC. From here, two voltage dividers resistors, R1 and R2. Now here, if we noted down the values of voltage and currents, so this voltage will be VB, this is VC, this is VE. So in between we have this voltage VCE. This current is IC. This current is IB. This current will be IE, which is almost equal to IC. This is the bias current I1 and I2. Now, in the case of approximate analysis, we will assume the base current is very small. Let's say this base current is equal to 0. It means this I1 and I2 will be equal. So we can say that R1 and R2 will be in series. So this is the first concept of the approximate analysis. So if we consume that R1 and R2 are in series, so the equivalent circuit only for the base we can draw as this is R1, R2, and this one was coming from the VCC. So this voltage, let's call it VBB, which is nothing but VB. So the equivalent circuit of the base is this. Now, this output voltage for the base is VB equals to VBB, which is, now we are going to use the voltage division rule, which is VB equals to R2 divided by R1 plus R2 into VCC. Okay, so we have used here a voltage division rule. So across a two series resistance R1 and R2, the voltage across R2 is first the main voltage for which is getting divided, which is VCC. So that voltage VCC multiplied by the resistance in which the voltage is being calculated divided by the total series resistance. Now, keeping this in mind, the equivalent circuit of the voltage divider we can draw now like this. This was plus VCC, this is RC, this is the NPN BJT, this is RE. Now from here we are replacing this base resistances with a voltage we just calculated, which is VBB. Okay, and here we have assumed that this current is IB, which is near equal to 0. This is the same old IC. This is VC. This voltage is VE. And the voltage between these two terminals is VCE. This is IE current, which is same as IC current. Now, once we are ready with this diagram, we can write the voltage divider biasing analysis values. It's like the first one, VBB equals to R2 divided by R1 plus R2 into VCC. This was in already. Now, if I apply the KVL in this loop, okay, where this voltage is VBE. Okay, so if we apply the KVL in this loop, I can write as plus VBB minus VBE minus IERE equals to 0, or plus VBB minus VBE minus VE equals to 0. So from here I can write VE equals to VBB minus VBE. Okay. Now again, if we know the value of VE, we can find the value of IE as IE equals to VE by RE. We know that IC will be near equal to IE, and as per the question, if we see, so we have to find out the value of IC. So the one value is expression is written here. I missed one more part. We need to find out the expression. So for one expression is IC equals to the ideal closed loop, and IE is voltage VE by RE. So VE means VBB minus VBE. VBE, this VBE is ideal 0.7 volt closed for the silicon, and this VBB we can find by using this formula. It means the value of IC can be known by using B or this analysis. So this is the first expression. So B value to find out using got at 0.96 and 1.0. Now second one, as per the questions, we need to find out as VCE. So let us proceed with this analysis. Okay, now 1 point VC is this 0, so it means VC4 from, so this is the VCC. If we voltage subtract ICRC, we will get the value of VC. So we can write like VC equals to VCC minus ICRC. Again, we'll see what we have done. See, this voltage drop across this resistance will be IC RC, and this voltage we have to find is VC. So from VC, this voltage minus this voltage is this voltage. So VC equals to VCC minus IC RC. Now we need to find out the value of VCE. So VCE will be VC minus VE as per definition. Okay, or this one VC minus VE we can write as IE RE. Okay, this VC we can write as VCC minus IC RC from here, minus IE we can write as IC. So IC, and then this is RE. So VCE will be VCC minus, from here if we take IC common, so we'll get RC plus RE. So this is the second expression which we need to find out. So with this, the first part of the question is completed, which is developing the expression for the operating point IC and VCE using approximate analysis. Now, second part of the question is we need to find out the operating point for given values. So let us redraw the circuit. Now, as per the question, what is given? VCC is 10 volt, R1 10 kilo ohm, R2 2.2 kilo ohm, RC 3.6 kilo ohm, and RE 1 kilo ohm. So let's write those values. So this is VCC, which is plus 10 volt, RC is 3.6 kilo ohm. So this is RC. RE is 1 kilo ohm, R1 is 10 kilo ohm, R2 is 2.2 kilo ohm. These are the given. We need to find out the operating point. Operating point means we need to find out the value of IC and VCE. So as per the previous analysis, we can directly conclude that VB or VBB, where is this is in the diagram, what is VB? This voltage is VB, this voltage is VBE, this voltage is collector voltage VC, this is emitter voltage VE, this is the collector current IC, and this is the emitter current, which is also equal to collector current by considering IB0. So this is the IB0 means approximate analysis, we are going to use it. Okay, so VB equals to VBB, which is, we just saw the formula was for this was R2 divided by R1 plus R2 into VCC. So R2 means 2.2 kilo ohm divided by R1 is 10 kilo ohm plus R2 is 2.2 kilo ohm and VCC is 10 volt. If you solve this, you will get the value of 1.8 volt. So this is the value of VB, which is 1.8 volt. Now what is VE? So we just saw that VE was VBB minus VBE. All this analysis we are using to solve this problem. Okay, so this is VBB is 1.8 volt and VBE by default it is 0.7 volt for silicon. So VE is 1.1 volt. So now once we know the value of VE, we can find the value of IE as IE equals to VE by RE. So in this diagram, this current is IE. So IE will be VE by RE. So we just calculate the value of VE as 1.1 volt. RE is given as 1 kilo ohm. So this will come as 1.1 milliampere. Okay. Now IC is same as IE, which is 1.1 milliampere. So this is the first operating point we have calculated. Now second one is VCE. So for VCE, first we need to know value of VC. VC is nothing but VCC minus ICRC, which is VCC is 10 minus IC is 1.1 milliampere and RC given as 3.6 kilo ohm. Again, if you solve this, we will get VC equals to 6.04 volt. Now, VCE equals to VC minus VE, which is 6.04 minus VE. Just now we solved as 1.1 volt. So this answer will be 4.94 volt. So this is the another value of operating point we have calculated. Okay, so with this question is completed. Please verify the calculation by yourself one more time. Okay, now let's move to the second problem, which is for the circuit shown in figure 1b. So this circuit you can see, this is from the topic common collector. So this is the ammeter follower or common collector. For this we have to find out the voltage gain and AC load voltage. Given beta is 150. Other values are also given. So let us solve this problem. So this question already I have written. Now what we need to find out first, we need to find out the voltage gain. Okay, so for this we know that the voltage gain so the formula is AV equals to RE upon RE plus RE prime. Okay, so here the detailed derivation is not required. If you remember the formula, that is enough for us. So the formula for voltage gain AV equals to RE upon RE plus RE prime, where this we need to find out these values. So the RE is nothing but it is capital RE parallel to RL. So those values are given in the question. Capital RE is 2.2 kilo ohm and RL is 6.8 kilo ohm. Okay, so this is nothing but 2.2 kilo ohm parallel with 6.8 kilo ohm, which is 2.2 into 6.8 divided by 2.2 plus 6.8, and if we solve this, we'll get as 1.6 kilo ohm. So this is the value of RE. Now RE prime. What is RE prime? RE prime is 25 millivolt by capital IE, where capital IE is the DC emitter current. Now to find out this capital IE, we need to find out the DC values. So we are going to perform the DC analysis. So for DC analysis, what we'll do is from the circuit, DC analysis means these capacitors will be open. So remaining circuit we are going to solve. So if you see that remaining circuit, we will get like this part of the circuit for the DC analysis. So let's redraw this. This is the plus VCC. So this value of VCC is given as 15 volt. Okay, then R1, R1, R2, and both is given as 4.7 kilo ohm. So 4.7, 4.7. So this is the DC part of the circuit. So now what we need to find out? IE. What is IE? IE is this current, this voltage is VE, this voltage is VBE, and this voltage is VB. Okay, so what is VB? VB will be, see, R1 and R2 both are equal, so anyway VB will be half of the VCC. Or if you want to use the formula, we can use that R2 divided by R1 plus R2 into VCC. By the way, this formula is not required because we know that R1 and R2 are both are equal. So VCC will be divided equally. So 7.5 answer, we should get it. So this is 4.7 divided by 4.7 plus 4.7, they are all in kilo ohm, into 15. So this is 2 times of 4.7, so 1 by 2, so answer will be 7.5 volt. That is the value of VB. Now, what is VE? If you look at the circuit, so VE is nothing but VB minus VBE, which is 7.5 minus 0.7. So if we solve this, we'll get the value of VE. So if we do this, we will get as 6.8 volt is the value of VE. So once we know the value of VE, we can write the value of IE as VE by RE. So IE will be VE by RE. VE is 6.8 volt. RE is given as 2.2 kilo ohm. So V is 6.8 volt. RE is 2.2 kilo ohm. So if we solve this, we'll get at 3.09. So this will come as 3.09 milliampere. So this is the value of IE. So once we know the value of IE, so now this we can calculate as RE prime as 25 millivolt by IE equals to 25 millivolt by 3.09 milliampere. So 25 by 3.09 is 8.09 ohm. So this is the value of Re prime. Now using all these values we can find the value of voltage gain. So AV equals to Re by Re plus Re prime. So Re is we have calculated here as 1.6 kilo ohm, and again divide by 1.6 kilo ohm plus Re prime as 8.09 ohm. So now let us solve this. So after solving, we will get as the AV as 0.995. Now one thing we can see here is it is the common collector or emitter follower. Emitter follower is the voltage gain is almost equal to 1. Here also we can say that the voltage gain came as 0.995. So this is the first part of the question, which is find out the voltage gain. Now next is we have to find out the AC load voltage. AC load voltage means the output voltage. It means voltage at this point. Okay. So the AC load voltage or the output voltage is simply so the load voltage or the AC output is by formula V out equals to AV V in, where AV is the voltage gain, V in is the input voltage. Input voltage means uh, the voltage at this point, V in. Okay, now what will be V in? If you look at here, let me remove some part of this. Okay, now here, if you look here, this is the input impedance looking at the base. So Z in base, if you look at here, so it is input impedance looking at the stage. Now here in numerical problem, the detailed derivations are not required. So if we remember the formula, that is enough for us. So V in will be the voltage here looking at this point, V in. So V in means, now if you look this part, so what we can see? We can see this is the voltage Vg, source voltage. This is the resistance Rg, and then for AC, capacitor will be shorted. So capacitor will not be here, it is shorted here, and here this will be Zin of stage. Okay, so here I can write again by using the voltage division rule that V in, which is here across Z in stage, so V in will be Vg into G in stage divided by Rg plus G in stage. So if you continue here our analysis, so the formula first we have written on this, V out equals to AV into V in. Now what is V in? V in will be Z in of stage divided by Rg plus gene of stage into Vg. Okay, so this analysis we have used to write this formula. Okay, now here AV is known here. Okay, now we need to find out the value Rg is given. So we need to find out the value of Z in stage. Okay, so what is Z in stage? Again, by the formula, Z in stage equals to R1 parallel to R2 parallel to Z in base. Okay, again, if you look at the circuit part, question part, so this part is looking from here, it is Z in base. Okay, now again we need to find out the value of Z in base. So the formula for Z in base equals to beta times Re plus Re prime. Now all values we know. Beta is given as 150, Re is 1.6 kilo ohm, and Re prime is 8.09 ohm. Let's all put all these values here. So it is 150. Okay, Re is 1.6 kilo ohm plus Re prime. Re prime is 8.09 ohm. So let us solve this and we'll find the value of Z in base. So this we have got as, after solving this, we got as a 241.2 kilo ohm is the value of Z in base. So now, what is Z in stage? Will be R1 parallel R2. So R1 is 4.7 kilo ohm. Kilo ohm I'm not writing, is understood. 4.7. R2 is again 4.7. And then this will be Z in base is 241.2. All these values are in kilo ohm. So let us solve this. So by solving first 4.7, 4.7, if we have a parallel, so we'll get half of this. So it is 2.35. Again, this is in kilo ohm, parallel to 241.2 kilo ohm. Now, after solving this, by using product by some method, we will get as 2.33. So this all values are in kilo ohm. So 2.33 kilo ohm. Now we know the value of Z in stage. Now we can find the value of V in. So V in will be, so previously we saw V in by using this formula, Z in stage by Rg plus Z in stage into Vg. All values are given. Vg is given as 1 volt and Rg is given as 600 ohm. So putting all these values, what we will get here is, so first value is Z in stage, which is 2.33 kilo ohm divided by Rg. Rg is given as 600 ohm in the question, 600 ohm. Okay, plus again Z in stage plus 2.33 kilo ohm, and this will be multiplied by Vg, which is 1 volt. This is given in the question here. Vg equals to 1 volt. So after solving this, we'll get the value of V in. So I got as near equal to 0.8 volt. Okay, so this is the value of V in. So now finally we need to find out the value of V out. So V out will be AV V in. AV, how much we got previously? AV is 0.995. So AV is 0.995 and V in, we just saw it, 0.8 volt. So after solving this, we'll get the value of V out 0.995 into 0.8. So this will come as 0.796 volt. So this is the value of the AC output. Please verify the calculations by yourself. I might have done some I may do some calculation mistake because I'm solving this in real time. So I hope you're understanding the method how we are going to solve it. Calculations and all verify once more from your side. Okay. So this is the second problem we have done. Voltage divider bias circuit to meet the following specifications. VCC is 10 volt, VCE at midpoint, step voltage divider, collector current 1 milliampere, beta DC range is given as from 70 to 200. Okay, so let us write the problem first. So now we have a design problem here is, so to design a voltage divider, we need to follow a few steps. So what is the first step? First step is we have to start by assuming let VE equals to 0.1 VCC. Now at this point of time, I want to tell you is there is no unique way of designing any circuit. Okay, but we are going to follow this method to design. Different books may suggest different methods, but almost all are the values will be same. So here we are going to design by assuming the first VE is 0.1 times of VCC, which is 0.1 into VCC given as 10 volt. So this will come as 1 volt. It means we are going to design the values for the VE will come as 1 volt. So it means what should be the value of RE? RE. So here let us see the diagram of a voltage divided by a circuit. So this is RC, then here we have transistor, this is RE, these are R1, R2. Now designing means we need to find out these register values for given specification. So this value is given as 10 volt. Okay, this is VE, this is VC, so this has to be VCE, this is IC, this current is IE, and IE is same as IC. Okay, let's call this voltage as V1, this voltage as V2. Okay, so now first we are going to design for VE equals to 0.1 times of VCC, which is 1 volt. Then what should be the value of RE so that VE is 1 volt? That we are going to find out. So RE is VE by IE, which is 1 volt by IE is, see here, the collector current is given as 1 milliampere. Collector current is same as the emitter current. So 1 milliampere, so which is 1 kilo ohm. So this should be the value of the RE. Now next one is, since we are going to design for the stiff, so it means for stiff sorry voltage divider, what is the condition? Condition should be R2 should be less or equal to 0.01 times beta DC RE. So this is the condition for a step voltage divider design. Okay, so R2 should be either less or equal to. So we are going to assume the value of R2 is equal to, because designing we are going to do. So we just need to follow these conditions. R2 can be either equal or less than that. So we are considering for equal design. So 0.01 into, now beta DC. Beta DC, what value should we take? Beta DC range is given as 70 to 200. So here the catch here is we should take the lower value. Okay. So lower value is 70. And what is RE? RE is 1 kilo ohm. So if we solve this, we will get the required value of R2. Okay. So required value of R2 came as 700 ohm. So this is the value of R2. Okay. So RE is a R2 over RC. RC is also important. So actually RC we should do here itself before this. Now RC again, as per the design steps or procedure, RC should be 4 times of RE. Okay, so RE is 1 kilo ohm, so RC should be 4 kilo ohm. Okay, so RC over RE over R2 over, now R1. R1 we need to find out. Okay, first see what is V2. So V2 will be, if we take here in this condition KVL, so what should be V2? V2 should be VE plus VBE. So this voltage is VBE. VE already we know. So what is VE? VE come as 1 volt. So 1 plus VBE by default 0.7 volt. So this should be 1.7 volt. It means this value is 1.7 volt. It means what is the voltage across R1? It will be nothing but 10 minus 1.7. So we can write V1 will be VCC minus V2, which is 10 minus 1.7, which is 8.3 volt. So this is V1. Okay. Now, what is R1? R1 will be V1 by V2 into R2. Again, here derivations are not required. If you remember the formula, that is enough for us. But even then, if you want to use the voltage division rule, you can always find out here as what. So this V1 is nothing but this VCC minus V2. So this is the value of V1. We have got it here. So using the simple analysis, we can find these values. So what is V1? 8.3 divided by V2 is 1.7 into R2 is, we got as 700 ohm. Okay, so let us solve this. What will get? 8.3 divided by 1.7 into 700. So the answer we are getting as 3.42 kilo ohm. 3.42 kilo ohm is the value of R1. Okay, so with this, the design is completed. Again, please verify the calculations by yourself. I hope you understood how to solve this kind of problem. So this problem 2b is from the topic the loading effect of the input impedance. So this circuit is given. So we have to find out the output voltage. Okay, so again here derivations are not required. We will use the direct formula. Okay, so first of all, we know the voltage gain AV for this circuit is RC by RE prime. Okay, now what is RC? RC is RC parallel. So this RC is capital RC parallel RL. Okay, now what is capital RC? This is capital RC. So this is 3.6 kilo ohm parallel to RL as this is 10 kilo ohm. Okay, so if we solve this by using product by sum, so 3.6 into 10 divided by 3.6 plus 10, so this will come as 2.65 kilo ohm. Now RE prime. So what is RE prime? RE prime is 25 millivolt by IE, where IE is the DC emitter current. So to do this, we need to find the DC analysis. DC analysis means from this circuit, we will open the capacitor and remaining part is the DC part. So let's read out the circuit. Only the DC circuit has. So this is plus 10 volt VCC. Then this is RC 3.6 kilo ohm. Then this is the transistor. Then this is RE, which is 1 kilo ohm. And from here, this is R1. And this is R2. R1 given as 10 kilo ohm, R2 given as 2.2 kilo ohm. Okay, so this is the DC part of the circuit. So from this circuit, we have removed the capacitor and remaining part is the DC part. Okay, now this voltage is VB, this voltage is VBE, this voltage is VE, and this current is the emitter current. Okay, so first part of the DC analysis is finding the VB, which is your R2 divided by R1 plus R2 into VCC. So R2 is 2.2 kilo ohm divided by 2.2 kilo ohm plus 10 kilo ohm into VCC is 10 volt. Okay, so if we solve this, we will get as 1.8 volt. Okay, so we know the value of VB. Now what is VE? VE is VB minus VBE, which is 1.8 minus 0.7, 1 volt. Okay, so this is the value of VE. Next, IE. IE is VE by RE. So VE is 1.1 volt. RE is given as 1 kilo ohm. So this will come as 1.1 milliampere. Now we put this value here. So RE prime is 25 millivolt by 1.1 milliampere equals to, if we solve this, we'll get 22.7 ohm. Now, if we know the value of RE, using this formula, we'll get the value of the voltage gain. Okay, so now AV equals to RC by RE prime. How much RC we got? RC was 2.65 kilo ohm. So 2.65 kilo ohm. And how much we got RE prime? RE prime is 22.7 ohm. 22.7 ohm. So let us solve this. So 2.65 kilo ohm divided by 22.7 ohm. If we solve this, we will get as 116.7 is the voltage gain. Okay, so what is the question? Output voltage we have to find out. So if we know the voltage gain, so what is the output voltage? Okay, so we know that the output voltage V out will be AV V in. AV we just saw it 116.7. Now we need to find out the value of V in. Again, V in means voltage here. So if I change the color, V in is the voltage here. Okay, looking at this, this is your Z in stage, and looking at here, this is the Z in base. Okay, so it means so V in will be Z in stage divided by RG plus Z in stage into VG. Okay, now what RG is given the question. Now we need to find out the value of Z in stage. Okay, so Z in stage will be your R1 parallel to R2 parallel to Z in base. It means now we need to find the value of Z in base. So Z in base equals to beta RE prime. Okay. So again, here we are not doing the derivations, directly formula we are using, because it is a numerical problem. Here derivations are not required. So beta is given as 300 and RE prime we just calculated as 22.7 ohm. If we solve this, Z in base will come as 6.8 kilo ohm. Putting this value in Z in stage, so Z in stage will come as R1 is given as 10 kilo ohm, which is parallel to 2.2 kilo ohm, which is parallel to 6.8 kilo ohm. Again, if we solve this, we will get as 1.42 kilo ohm. Okay, so this is the value of Z in stage. Now putting all these values, we'll find the value of V in this formula. Okay, so what is V in? V in will be 1.42 kilo ohm, which is the Z in stage. Okay, divided by Rg is given as 600 ohm, and again Z in stage is 1.42 kilo ohm, and Vg is given as 2 millivolt in the question itself. So 2 millivolt is given here. Okay, so after solving this, we will get as 1.41 millivolt. It means using all these things, V out is AV, V in. AV was, we calculated AV here. This 116.7. So 116.7 V in is 1.41 millivolt. So if you do this, 116.7 into 1.41, we are going to get 164.55 millivolt is the value of output voltage. Okay, so this is how we'll do this problem. Okay, so this is a simple problem, and please verify the calculations again. Okay, now let us move to the next problem. Now 3a, with neat circuit diagram, explain biasing of MOSFET by fixing the gate voltage. So this is the direct problem. Refer the class notes or the textbook. You will easily do this by yourself. Here my explanation not required. Please refer the class notes or the textbook. This is the topic, that biasing by fixing VG and connecting a resistance in the source. Same with 3B. 3B also is a direct problem. With neat circuit diagram, develop an expression for the voltage gain, input impedance and output impedance for common gate problem, common gate amplifier. So this is the common gate amplifier. Again refer the class notes. There detailed derivations it's given. Also you can refer the textbook also. So these are the direct problem. 4a is also a direct problem. Derive an expression for drain to source voltage for a MOSFET amplifier using drain to gate feedback resistor. So it is the biasing problem, biasing topic, biasing of MOSFET. So this is also direct. This one, develop an expression for transconductance in terms of drain current and overdrive voltage. It is only for the 4 marks. So this also is a simple one. Let's see how to do this problem. So this is which it's problem 4b. So here what they're telling you to find out transconductance in terms of the drain current and the overdrive voltage. So we know that the transconductance Gm equals to Kn prime W by L POV. Okay. Now, in this formula, what is the value of ID? ID in saturation is half Kn prime W by L VOV square. Okay. So from here, these terms I can write as Kn prime W by L equals to 2ID by VOV square. So this I have taken left hand side, other things I have sent right hand side. So this we have got it. Now put this value into this, because they are telling us in the question that develop an expression for transconductance in terms of drain current and overdrive voltage. Okay, so this we have going to replace. Okay, so if I put this value into this, what we'll get as gm equals to kn prime w by l, which is 2 id by vov square into vov. Okay, so now this vov will be cancelled by this, so I can write the transconductance gm equals to 2 id by vov. This is the final answer. We have expressed the transconductance in terms of the drain current and overdrive voltage. Okay, now the next question: with neat circuit diagram, develop an expression for voltage gain, input impedance and output impedance of common source amplifier without source resistance. Again, this is the direct, you can get it from the textbook or the notes. 5 is also a direct problem. With neat circuit diagram, explain the operation of R2 to R that. So this also, please refer the textbooks. Now here 5b, there is a numerical here. So what they're telling, for the circuit shown in this figure, the input voltage is a sine wave. So this input voltage is a sine wave with peak value of 10 volt. Determine the trip point. Trip point means reference point. Also plot the input output waveform. So let us solve this problem. This is the problem from the topic comparators with non-zero reference. Okay, so here what we need to find out, we need to find out trip point. Trip point means voltage at this place, which is Vref. Okay, so this we need to find out. So what will be Vref value? Vref is nothing but the trip point. The trip point is Vref, which is, so here again we are going to use the voltage division rule. So this place, if you see in series resistors, so you'll get that 100 kilo ohm divided by 200 kilo ohm plus 100 kilo ohm, and this will be multiplied by 15. Okay, so simple with voltage division rule we have used this. So after solving, you'll get that plus 5 volt. It means the trip point is plus 5 volt. This is the first part of the question, which is that determine the trip point. Now we have to plot the input output waveform. Okay, so let us redraw the circuit with the trip point. So this is the op amp, plus VCC is plus 15 volt, minus V is minus 15 volt. This is the V out. So here the input is given as the non-inverting terminal and input is given as 10 volt peak. Now here from this circuit, after finding the Vref, we can find out here this is a DC value which is plus 5 volt. It means the trip point here we have received. Okay, now we need to find out the waveform. So let us draw this. So first the input waveform is, it is a sine wave. So sine wave will be like this. Okay, now here this will be the, let us draw a line. Okay, so this is the reference. So this is Vref equals to plus 5 volt. This is value is 10 volt given here, 10 volt peak value. Okay, now let's see some of the reference points. So like that here, here also one reference point we'll get. Then for the second cycle also here, and here. Okay, now if we want to draw the output waveform, let us take here on the same scale. So this will be, now what happens is, this is the comparator. So as long as this value at this is more than this, the output will be plus Vset. If this terminal value is less than this, output will be minus Vset. Okay, so here in this range, this range, the input voltage is more than the reference point. So here this value will be plus Vset or plus 15 volt here and here. But in this range, here, 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 the input voltage is less than the reference value. So there the output will be minus 15 volt. Okay, here. So from here this transition will occur. Let me draw a straight line. It is a little difficult to draw. Let me use the line option. Similarly, here, here, here. So this is the output waveform. So whenever the non-inverting voltage will be more than plus 5 volt, output will be plus 15 volt. Otherwise, the output will be minus 15 volt. So this is the answer for the second part of the question. I hope you understood it. Now let's see the other questions. 5C with Schmitt diagrams explain the operation of Schmitt trigger. Again, this is the diet question. Please refer the textbook. Next, 6A and 6B, they are also the direct questions for the textbooks. So this is for 555 timer diagram, and also this is for the Wien bridge oscillator. 7A, sorry, classify negative feedback amplifiers and explain each with neat block diagram. So again, this is the direct problem. We have to do the classification. So like one is voltage controlled voltage source, then current controlled voltage source, then voltage controlled current source, and current controlled current source. So all the four we have to draw the block diagram, okay, and explain about the input and output impedances. So this is the direct problem. Please refer the textbook. Now 7B is a numerical problem. Let us do this. So in 7B, a diagram is given. We need to calculate the feedback fraction. It means the fraction of the feedback B we have to find out. Ideal closed loop gain, percentage error and exit closed loop gain, and we have to use AOL value as given in the question, and the IC is 741C. Okay, so let us solve this problem. This is the problem from the topic voltage controlled voltage source. Okay, now here just this question I have written. Okay, so first one, the feedback fraction. So the feedback fraction, we call it B. B is nothing but what is the amount of feedback fraction? It means it is this voltage across 100 kilo ohm is taken here. So here it is, let me see the question again. Okay, so the feedback fraction is 100 kilo ohm divided by 100 kilo ohm plus 3.9 kilo ohm. Okay, so it means, see this, we assume this current to be zero. It means this resistance and this resistance are in series. So in series we have used the voltage division rule. So it is B equals to how much fraction will be given to the input. So it is the voltage across the 100 kilo ohm, but only fraction we are calculating, we are not multiplying with the voltage. So if we solve this, we will get the value of B. So what is the value of B we are going to get is 100 kilo ohm by 100 kilo ohm plus 3.9 kilo ohm. So 100. So we'll get at 0.96. So 0.9, 0.96. So this is the feedback fraction. Now next they're asking is the percentage error. So again the formula, the percentage error, by formula it is percentage error equals to 100% divided by 1 plus AOLT, okay, equals to 100%. 1 plus AOL is given as 100,000. So this is given the question. AOL B is 0.96. So B value from here we have taken 0.96. So if we solve this, we will get the percentage error. So after solving, we have given as 1.04 into 10 to the power minus 3%. Okay, so 0.000104 like that something it will come. Okay, so I written in these terms 1.04 into 10 to the power minus 3, that much percentage. So this is the second part. Exact closed loop voltage gain is the third part. Okay, so what is the exact closed loop voltage gain? So AV will be AVOL by 1 plus AVOL B. Okay, so it is AVOL is given, B 0.96. If we solve this, so 1.04, so get at 1.04. Okay, so this is that not derivative formula, so derivations are not required. Okay, so please kindly verify the calculations. I missed one more part. We also need to find out the ideal closed loop voltage gain. Okay, so the ideal closed loop voltage gain AV. So ideally it is 1 by the B, which is the feedback fraction. Okay, so B value we got at 0.96, so 1.0.96. So this will come as 1.04. So this is the ideal closed loop voltage gain by yourself. Okay, now let's move to the next problems. So next one is with need circuit diagram expressions explain current amplifier. So current amplifier means current control current amplifier. You have to do this current control current source. So this is again direct. Please refer the notes. 8a, classify the filters and explain the ideal responses for each of the filters. Again refer the notes or textbook, you will find out. So we have to classify the filters like low pass filter, high pass filters, band pass filter, all pass filters, okay, band reject filters, and all we have to classify. 8b, with this circuit diagram explain the operation of first order low pass filter and high pass filter. Again direct questions, please refer the notes. 9a, with neat circuit diagram and waveform explain SCR phase control using RC circuit. Direct question. With neat circuit diagram explain the operation of UJT and hence explain how it is used as a relaxation oscillator. This is also a direct question. For all these direct questions, refer the notes of the textbook. Make use of a breakover characteristics to explain the operation of 4-layer diode. Again direct question. Write short notes on the IGBT. This is also a direct question. Explain bidirectional thyristors in brief. This is also a direct questions. So usually from this topic, thyristors and this one silicon control rectifiers, oscillators and all, direct questions they ask. But here one topic question they have not given from the power amplifier, class A, class B amplifier, they have not given, but they are also very important. Like class A, operation of class A, operation of class B, push-pull amplifier. Class C, they can ask on a short notes, but in this model question paper, that is not mentioned. But you have to do study that also. So I hope in any way I have made this video. I hope it will be useful for you. Okay. Okay, then all the best for examinations.